Good morning. My name is Nelson Jetel with the Okanagan Basin Water Board. Welcome to the May 8th, 2018 Okanagan Water Supply Webinar. We are joined with another great panel this year, and over the next hour or so, we'll have an opportunity to get an update in terms of the status of water in the Okanagan and some of the issues that we'll be facing this upcoming year, some of them obviously relating to flooding. So once again, my name is Nelson Jetel. This is brought to you by the Okanagan Basin Water Board and a range of partners that are co-presenting with me today. And just to note that the purpose of the Okanagan Basin Water Board is to provide leadership to protect and enhance quality of life in the Okanagan Basin through sustainable water resource management and communication tools like this today. So this is intended to be a relatively high-level and yet detailed analysis of where the Okanagan water supply is today. This is a snapshot looking south from OK Falls there, with Skaha Lake in the foreground and Okanagan Lake in the background. And one of the interesting things, because we have an interconnected set of systems, oftentimes by minimizing flooding, in this case in one system, can cause issues in others. There's significant variability in terms of input. This graph, which we show pretty much at every webinar, identifies the annual net inflow into the Okanagan system. You can see 2017 is the red bar on the far right, where we had some significant lake flooding, but by no means was it the highest recorded water input. This year we're looking at once again some pretty significant water supply coming into the system. But I think, as you may hear from a number of speakers today, so much of the annual input really depends on the rains that we get in May and June coming up. This graph talks about the demand for the Okanagan, and it really identifies, first of all, where we are. We're at week 19. We're anticipating that the demand is going to increase pretty significantly, and most so for human and agricultural consumption as we get into July, August, and September. And as we've identified in the past, that August, September, and October window are also critical for environmental flow needs for fish, and it really does turn into a challenge sometimes to be able to manage during that shoulder season in the Okanagan. And as we look at today's supply info, it's interesting both to be able to identify ways to be able to mitigate for flood challenges, as well as shoulder droughts and some of the forest fire issues that we'll be talking about. One of the interesting things that's showing up in the climate record is the change in hydrograph. This shows sort of a modeled version of the Okanagan Peak. This is looking at White Man Creek, which is on the west side of Okanagan Lake, North Okanagan Lake. And it effectively shows that there is a shift so that there's earlier snowmelt, and it ultimately increases the tail of potential drought and issues in August or September. So today we're going to be covering off a number of different slices of the picture for the water supply in the Okanagan. We're going to be talking about the flow and the snowpack, Okanagan Lake and the downstream river, as well as some of the other main stem lakes, including Osoyoos Lake. We're going to be talking about groundwater and sort of some of the interconnectivities and issues related there, precipitation and more weather in general. And we'll also be talking a little bit about the fire potential and risk for this upcoming year. So this is your panel for today. We've got myself kickstarting things off, and then we'll be hearing from Dave Campbell from the BC River Forecast Center, followed by Shaun Reimer, who's joining us from Flynn Row, and he'll be talking about the Okanagan Lake Dam and some of the things that are going on in Okanagan Lake. We'll be hearing from Gwen Graham, who's with Environment and Climate Change Canada, and also sits on the IJC, and he'll be talking about Osoyoos Lake Nicole Pyatt from Flanroe RD will be talking about groundwater supply and how things are looking throughout the region. We've got Doug Lundquist, who's in the office with me today, and he's with Environment Canada and Climate Change, and he'll be talking about the weather and some of the forecasts. And then we'll wrap things up with Ray Crampton from Flanroe RD talking a little bit about the fire season and some of the risks anticipated with that. So just very quickly, as always, we're keen at the Okanagan Basin Water Board to identify better information to support better decisions on Okanagan waters. The OBWB has been around since 1970. This is our 5th year doing these Okanagan webinars, where we have some pretty significant uptake from local governments and the ag sector throughout the region, getting a sense of what the current supply is and what some of the forecasts for weather may look like. We have a mandate to deal with water governance and management and really support collaboration and community communication. We strongly focus on the sense that we've got one water and one community in the Okanagan watershed, and there's multiple needs, including human applications, of course, but also agriculture and food security, and the need for ecosystem and environmental flows, including fish. The Okanagan Basin Water Board takes a regional approach to our practical water management issues, and we appreciate that there's variations between drainages, and we'll see that as some systems this year are experiencing significant flood events and others are doing much better. Each water source needs its own water management strategy, and because we're connected, we need coordinated strategies, and today is largely about supporting some of those coordinated efforts. Okay, with that, I will turn the mic over to Dave Campbell from the River Forecast Center.
All right, thanks, Nelson.
Thanks, Dave.
And so I'll run us through a little bit just where we're at with the snowpack. If we go to the next slide, if people were on the last call, really kind of where we were at with April 1st snow levels. And generally speaking, April 1st is a prime time for us because we generally have the bulk of the snow that we expect to see on the ground. The one piece that kind of, and typically we start to melt that snow as we go from April into May. And as I go through the discussion, the kind of the back of mind thinking about is that, really in terms of elevation and where we're at within the watershed, that transition takes place at different times. And so in a normal year, we will start to melt off the snow in between April and May, and by May we're generally into that melt cycle. And I'll talk a little bit, but as we go into this year, we've kind of got a bit of a tale of two things where certainly at the low mid elevation, we're seeing that rapid melt, and then we're a little bit late in terms of the onset of melt at upper elevations. We also have the potential there for things to grow in terms of the snowpack between April and May. So when it comes to the May or that difference between April and May, we're really kind of looking to see how those trends are playing out. As we came into April 1st, obviously recognizing that we had significant snowpacks in the Okanagan, we were 152% of normal for the basin index value. And that's really made up of looking at some core indicator sites around the watershed and then kind of relating those to their normal level. So we go to the next slide. I'll zoom in on the specific measurements throughout the basin that were taken for May 1st. And so the first number is the measurement in snow water equivalent. The second measure is that percent of normal. So that's just taking that number and dividing by what it should be. And really, we can start to get very high percent of normal numbers. And oftentimes it's because in a normal year, we'd be melting quite a bit out. And so the difference between what we observe and what we normally have is quite large. It's not always reflective of a specific growth in the snowpack itself. So that's what the third number is in each line, is the change that we've had at that site between April and May. And so negative means we've started to melt, we've lost that much water, and then if we've added it, we've put a plus. So we can really see, broadly speaking, the areas where we get the biggest percent of normal readings are kind of more in the mid-elevation sites with not a lot of snow water equivalent. We're in that 300 millimeter range for this time of year. and we've seen a fair bit of melt happening, particularly kind of in that 1,400, 1,500 meter level and below. We've had rapid melt over the last 10 days or so. We can look at Brenda Mine's pillow, for example. It was 129 millimeters down from its April 1st reading. Of that 260, that's actually from the May 1st bulletin, or the May 1st survey period. We're May 8th now, we're down to 90 millimeters. So you can really see that, we're melting through snow about 30 millimeters a day at the lower elevations. Where we've got lots of snow are the upper elevation locations, so things that are, either high elevation terrain to the east of the watersheds. So places like Mission Creek have abundant snow and lots of it left, as well as some of the higher terrain over areas to the south east of Oliver, for example, where like Mount Cobo, for example, 184%, but we've still got quite a bit of water equivalent there. So we roll this up onto the next slide, looking at the basin index for May 1st. Again, not surprising, two things going on. Those upper elevation sites have grown in terms of the snow content, so we do have much more snow, just water itself in the snowpack. And then the other aspect of a little bit of a delay in terms of the onset of the melt season at mid elevation, and that's driving up those percent to normal numbers. So while the number's grown by 50% or more, the amount of snow that we've got has grown more, kind of basin-wide average, something in the order of 10 to 20%, and maybe a little bit on that lower end of that. But so sort of a mix between growth of snow, snow water, and difference between melt. Next slide. Again, kind of telling that story from the pillow data, or the snow weather station data itself. We can see this is current to today. So you can see that rapid melt at Brenda Mines have gone from the latest it's ever been in terms of that onset of melt, pretty much. We were at a record there when it started to melt, and rapidly have transitioned back to normal snow conditions for the time of year. Obviously, that's a lot of melt, and that water is coming down and causing a number of issues. Higher elevation sites, so that Brenda Mines at 1,450 meters elevation. It's pretty typical of that 1,400 meter band. We're getting very close. We've probably only got a few days left of snow. There, as we get into kind of more 1,500 meter grayback, is at 1,550, we can see we've melted about a third of the snow there. And then we go to the higher elevations like Mission Creek. We're in the melt cycle now, but really only maybe melted 10% of the snowpack that's up there. Next slide. Showed this last time, just looking at the seasonal hazard side of things. It's probably a little bit overestimated for the May 1st, but certainly we really do have extreme flood risks with the high snowpack this year. Obviously, that's manifesting itself in flood issues across the region right now, so I won't touch on it too much, but obviously we do have a critical phase of weather coming at us over the next few days here that we're concerned about for many of the rivers. And the experience is generally that this, as that mid-elevation snow disappears, then that risk starts to decrease. Most of the rivers are prone to impacts from that mid-elevation melt. So we're still in that critical period right now, and obviously this year is carrying quite a bit of flood risk that's manifesting itself into flooding right now. Next slide. This is just a snapshot of the revised seasonal forecasts. Shaun will talk more about the implications of these and kind of the reservoir management. But in terms of the seasonal forecasts, we've seen a fairly significant jump because of the growth in the upper elevation snowpack. So the forecasts themselves have probably come up about 20-25% from last month in terms of volume forecasted to come into the reservoir or lake system over the next 2-3 months. Putting it into context, we're kind of in the similar ballpark now of what the forecasted volume is relative to what the observed volume was last year. So just to kind of as a bit of context for what those numbers mean. Next slide. Again, just kind of showing people where information is available on the River Forecast Center website. We've got a bunch of real-time information as well as modeling that they can access, and again, gov.bc.ca/River Forecast Center. The next slide. When people are, and we're definitely finding that many people are turning to our model products that have come out, like the Clever model, which is now producing forecasts for the area like Mission Creek. I think people are getting quite excited. The model can produce extremely high flows, very sensitive to how we model the snowpacks within each basin. And that can produce, particularly as the model gets out, it almost exacerbates those small differences. And so oftentimes beyond about 5 days, the model can produce some very extreme flows that are not always realistic. And so our advice has really been to use extreme caution. I would not pin the model or use the numbers that come out of the model beyond 5 days. I think more just looking at the trends. On the less than 5 day range, things are modeling fairly well. We're aiming for in the order of 10% error on those, the 5 day less cycle. And so they are generally producing fairly good flows. I can show an example from Mission Creek. It's been modeling very well this season. And as I mentioned before, a current weather pattern coming in to the region, we've seen that steady rise and it is really tapping into that full suite of snow that's up in the basin right now. And so we are seeing dramatic and quite high inflow into the lake right now, as well as just the tributaries that are draining from mid and upper elevation snow are extremely high. Tomorrow is developing into a rainy pattern, so certainly into a phase in the next few days where kind of that flood concern is immediate for places like Mission Creek. Next slide. Just summarizing then, I mean, I've probably been focusing more on the flood side because that's kind of the world we're in right now. Obviously, the water supply side of things is also very critical, and I think the point that Nelson touched on is quite important. Looking at those climate change scenarios where that shift to earlier melt is expected to be kind of a new normal in a lot of ways. I would say it's maybe early to say, but maybe it's not, that this year is probably demonstrating that pattern. We've seen that shift early. We're seeing the melt come down quite quickly. I mean, it was delayed at first, but now it's very rapid. It's been very warm. And so certainly when it gets to kind of the unregulated creek later in the year, we're going to have that pressure of having melted the snow early. So that's probably a bit of a flag, despite the high snowpacks, that if we get into that drier pattern into the summer, that could still pose low flow risks into the tributaries around. In terms of kind of more immediate flood side of things, obviously the snowpack is abundant up high. We're rapidly melting the mid-elevation. And as I say, I think we're really in that critical window for flooding over the next few days and potentially for the next week or so here. So with that, I'll wrap it up and pass it back to you, Nelson.
Thanks so much, Dave. Dave, on the questions section there's a question from Jennifer Miles for you about some specifics about some creeks. So if you wouldn't mind just taking a quick check of that'd be great. Our next speaker is Shaun Reimer, and he'll be talking a little bit about Okanagan Lake levels. Shaun.
Sure, and I apologize. I'm fighting a head cold here, so hopefully will be understandable. So just so people understand where we're at, again, is that third week of April, Okanagan Lake started to rise. Again, typically it is that mid-April when that occurs. I'm showing a graphic here that includes the maximum recorded lake levels, but this has not been updated to include last year, so it's not showing where we were at last year. So we're actually just a little higher than our median flow for this time of year. And we are, for instance, about 60 centimeters below where we were for the same day back in May of 2017. And we do have a little bit of certainly room to go. I believe it's something like 50 some centimeters to go to full pool. So we're still... we still have a little bit of room there, and again, at this rate of increase, though, we're going to probably be peaking earlier than normal. Next slide. Our outflows are, again, have been kind of historic maximums in anticipation of the expected high inflows, and we were at our design maximum since sort of early April to try to draw down the lake. And just to, you see at the end, the green line shows that we've dropped. We did have to pull back our flows because of our the flows in the Oliver region of the Okanagan River are significantly higher than they are in Penticton. In the range of the differential is about 45 cubic meters per second. That's about as high as we've ever seen that differential, so it is a cause for concern, and it's that kind of flow creates wholesale issues down there. And again, because of this weather pattern that we're seeing, and the possibility that those flows could jump even more, and particularly the tributaries in the South Okanagan that feed the Okanagan River, we have temporarily cut back our flows out of Okanagan Lake. Again, after a few days and after this weather pattern has gone through, we'll reevaluate that. Next slide. So David showed this slide or something very similar to it. On Monday, we received our inflow forecast for the May to July period. Unfortunately, it was higher than even our April to July forecast. And previously, we had thought that our management would be able to keep us within sort of our or below full pool on Okanagan Lake. Right now, the projections are showing that we would go a little bit above, and that would be more in the line of 10 to, say, 25 centimeters above full pool. And like I've said in many of these phone calls, it is so conditional on the precipitation and also conditional on the how quickly the water comes into the lake. And based on what's happening right now, unfortunately, it's a bit of a worst case scenario. With the early snowmelt and the water coming in all at once, it gives us more limited options as far as being able to send water down. It would be much better if the inflow and the snowmelt was drawn out, and every day we can send more water down. Kalamalka Lake, I don't have a good feeling for it at this point. Kalamalka Lake hasn't really responded in the same way as Okanagan Lake, and I mean that although we have a high inflow forecast for it, it's only rising by less than 2 centimeters per day, and we're actually getting to a point where there's not much high elevation snow. There's very little high elevation snow that feeds into the Kalamalka and Wood Lake watershed. So I would think that within a week or two we'll be more or less out of snow then. We are seeing, of course, a large groundwater influence on that lake, and we certainly thought that last year that continued to feed Kalamalka and Wood Lakes and rise after the snow had melted. I guess that's about all I have for now. Oh, okay. And then this is, sorry, I forgot about this slide. This shows the sort of current inflow. The bottom is the cumulative. You can see that jump over the last week, and of course, based on the high weekly inflow. So, and over 100 million cubic meters, that's 30-some centimeters of water on the lake. Next. And that's it for me.
Thanks so much. Given your head cold, I appreciate how miserable those can be. Really appreciate you being here today and giving that presentation. Our next presentation is from Gwen Graham, who'll be talking about the IJC and Osoyoos Lake Board of Control and Osoyoos Lake levels. Gwen.
Thanks, Nelson. So the International Joint Commission, or IJC, has implemented water management orders on Osoyoos Lake, given the influence of Zozel Dam on regulating water levels on this transboundary lake, especially at certain times of year. The latest review of those orders was in 2013, but they do go back to 1946. The IJC Osoyoos Lake Board of Control monitors the provisions of these IJC orders, and that's where I play a role as the Canadian Board Secretary. So next slide. Here's just a map of the Okanagan and Similkameen River basins, and there are a couple of points that I'm going to highlight here, which I will be talking about in the next few slides. Obviously, you can see Okanagan Lake there as the dominant sort of storage reservoir, if you want to call it that, on the system. The Okanagan River flows down through into Washington State, where it becomes the Okanogan River and flows into the Columbia River. Zozel Dam controls the lake levels on Osoyoos Lake. It's in Washington State. Obviously, Osoyoos Lake is transboundary. And the Similkameen River comes in just into the Okanogan River, just below the border, below Zozel Dam. And it has a major influence on the levels of Osoyoos Lake as well. So I'm going to talk about that a bit. Next slide. So here we have a plot of flows or discharge along the Okanagan River at the Oliver Station. So this is our main point of measurement for what's flowing into Osoyoos Lake from upstream. And what we see here, the blue line is the current this year's flow rates. The green shaded background is the period of record, so the maximum range of water levels on the system from 1943, and then we have last year's water level shown in the dark green line, just for sake of comparison, or sorry, not water level, but flow rate shown for comparison. So what we see here is an increase in the discharge effectively into Osoyoos Lake, starting in roughly mid-March, and that early increase is really the operations at Okanagan Lake, so the drawing down of the lake level in anticipation of freshet and building that storage capacity that Shaun talked about. And that operated basically through to mid-April, at which point freshet started to kick in, as Shaun mentioned, late April. And so the increasing discharge rates that we see from roughly the third week of April on are basically the flow rates that are being translated or transferred down the system from Osoyoos Lake as freshet inflows start to kick in. And then next slide will show what's happening below the dam at the Okanogan River near Oroville. And what we see here again, so there was some flow regulation on the discharge at Zozel Dam roughly through the winter into mid to late March. The flow control gates at Zozel Dam have been open since March 26th, and the discharge rate has been increasing along the Okanogan River, again, as that increasing flow rate gets transferred down the system from Okanagan Lake as it was drawing down. And then again, late April, we started to see freshet kicking in. And what's happened here, you see a sudden down drop in that blue line, a decline in the Okanogan River discharge. And I'm going to explain that a bit, but basically it's the effect of a backwater effect from the Similkameen River flows that are coming into the Okanogan River channel below where this gauge is, and essentially preventing discharge through the system. And this is sort of a natural phenomenon that affects lake levels on Osoyoos Lake. So I'll move to the next slide, which is the Similkameen River system. So here we've got, again, the dark blue line is the current year's discharge rate in cubic feet per second. The light blue line shows last year's discharge rate, and the blue shaded area is the period of record discharge from 1929 through to last year. So what we're seeing here is a very sharp increase in discharge in the Similkameen system. as freshet and snowmelt occurs. The current discharge is close to, as of around today, it's close to about 25,000 CFS. And I think the NOAA forecast for the Similkameen is suggesting that it will peak close to the end of the week, although, again, the earlier caveat around being careful with the projection of the models beyond a few days still applies here, but they are currently predicting slightly above 30,000 CFS as a peak by late Friday. But again, we'll see how that changes or if that holds true. So the mean annual flow of the Similkameen River is about 3.5 times greater than that of the Okanagan River, and the Similkameen flows into the Okanagan River below Zosel Dam. So high flows on the Similkameen effectively can impede or block the flow out of Osoyoos Lake through the Okanagan River. In extremely high flow conditions, the Similkameen flow can actually reverse and flow up into Osoyoos Lake. It's pretty rare. I think the last time it happened was 1976, but it can occur under really high flow rates. Generally, what we see, though, is once the discharge increases past 10,000 CFS, we start to see a backwater effect being applied on discharge along the Okanagan system. So that again explains that downturn that we saw in discharge below of the river below Zosel Dam. Just moving to the next slides and looking at what's happening on Osoyoos Lake itself. I've got last year's lake level hydrograph on the left and the current year on the right. The gray shaded area is the IJC rule curve showing the maximum and minimum allowable lake levels. Obviously, when freshet is running and we have very high natural inflows, the IJC rule curve will be exceeded. And as long as Zosel Dam itself is operating at full discharge capacity and not doing anything to hold back water, then they are effectively in compliance. So it's the natural effect just kicking in. And as soon as freshet peaks, basically once the water levels come back down to within the rule curve, then Zosel Dam has to operate to maintain those that maximum and minimum range, or will stay within that range. Looking at this year's plot, the initial rise in lake level again was largely due to inflows from the Okanagan River. That's from late March through to late April, and then from late April, last sort of third week of April, we've seen the effect of the Similkameen high discharge rates kick in, and that's that backwater effect that has had a really dramatic result on the rise of the lake level on Osoyoos Lake, and you can see that sort of near vertical line. So on April 27th, the lake was about 912 feet. As of today, it's currently at about 914.5 feet, which is getting pretty close to what we saw as the maximum lake level last year. So it looks like the lake level is going to continue a steep rise as long as the Similkameen River is the discharge on the Similkameen River is increasing, and so that's going to we don't really know how high it's going to go, but it's possible that we'll move beyond the top line of that graph, which is right now showing 915 feet. So this is a high water year for sure on Osoyoos Lake. And that's basically the information that I have to present today. The last slide just shows where you can find information on lake levels on Osoyoos Lake. There is those plots that I just showed you are available in real time, so you can see them increasing and basically plot or track the lake levels. And again, for further information, you can either contact myself or my U.S. Co-Secretary counterpart on the Osoyoos Lake Board of Control. So thanks very much.
Gwen, thank you very much. That was a great overview. Our next presentation is going to be around groundwater from Nicole Payette from Flanneau RD. Nicole, take it away.
Hi there. Thanks, Nelson. The next few slides are going to be providing a summary of the water levels currently observed in wells throughout the Okanagan in the Provincial Groundwater Observation Well Network. Next slide, please. So as in last session, these slides will show an annual cycle of data. So that's on the x-axis. We'll provide some information about water level below ground surface and some information on the start of record or when we started monitoring that particular location. There are a lot of colors up there. We have maximum ever recorded water levels in yellow, minimum ever recorded levels in red, and the light blue in the middle is showing the historical mean. In addition to that color scheme that I mentioned already, we also have information from last year, which is the green, and then information from this year, which is validated in purple and unvalidated in the darker blue. So if we're looking at this well from a deeper aquifer in Enderby, we can see it's a little bit less water than we had in the system last year, but it's between it's between mean and maximum ever recorded levels. Next slide, please. In another deep aquifer, we have a trend that's showing right along average and a little bit less water than was observed in the system last year. Next slide, please. So this observation well is located in the Hulkar, and it is in a shallow aquifer. You can see that the water level that's being observed is higher than ever recorded water levels in the system, and that the trend has started to increase earlier than has been observed in previous years for last year's high water levels, similar to was mentioned by other presenters. Next slide, please. We can see we've had a little bit of tapering off of the water levels in the Lumbee area, so we're still between mean and maximum recorded levels, but in the last little while we've had a bit of leveling off. So this is another aquifer that is close to the surface and in hydraulic connection with surface water, so that will change as surface water levels change in that system. Next slide, please. In Winfield, we're still higher than ever historically recorded record in the Winfield well. You can see, though, there's been a bit of leveling off since our last meeting. Next, please. So this is in Ellison, Kelowna, out by the airport. We're higher than ever recorded levels, following the same trend approximately as was observed last year in that well. Next slide, please. The next couple of slides are in the Kelowna area. So this one is the Rutland observation well. It's trending quite along the same lines that we saw last year. This is a deeper aquifer, and it is between mean and minimum ever recorded levels this time. Next slide, please. This well is in southeast Kelowna, the McCullough well, and again, a little bit higher water level than was observed last year, but between mean and minimum levels. Next slide, please. So down into the South Okanagan below Penticton, as everyone knows, that's where we've been observing a lot of the flooding in the last little while. Twin Lakes is currently definitely having some issues, and we're seeing that as well in the groundwater records. You can see in this slide and the next slide, we're above ever recorded water levels in that system. Thanks very much. That's the second one within Twin Lakes, and we're also a bit earlier in the season than was observed last year. Next slide, please. Willowbrook, also the scene of some flooding. We've got water levels you can see that have started to level out but are still above ever recorded levels. If you look at the y-axis, you can see it's quite close to the ground surface, so it doesn't provide a lot of space to absorb any of that water coming from the high the high surface water flows in that area. Next slide, please. Tucklenuit, higher than ever recorded levels. This is in Oliver on the east side of the valley. Next slide, please. And in another aquifer within the Oliver area, we're also higher than last year and higher than ever recorded levels. Next slide, please. So this one is interesting. This is actually a bedrock aquifer in Anarchist Mountain, so up in the hills outside of Osoyoos. And previously we had seen levels that were below mean and low water levels, but we're seeing now that the water levels are starting to steeply rise within this bedrock system. And so this bedrock system is also starting to develop higher water levels that are going to feed water being released in the valley, as water is always trying to flow from high pressure to low pressure. So we can see that with some of that snow melt in the hills, the water's moving down through the groundwater systems towards the valley, where we're already having some difficulties. Next slide, please. So in general, we're still seeing the same trends we saw about a month ago as things kind of move a bit slower in groundwater. So we still have shallow aquifers that are above average to historically high. We have seen some leveling out in some of the monitoring locations. With the exception of Anarchist Mountain, we've got deep, high elevation aquifers that are average to below average water levels, but they're starting to come up in some areas. And we're still seeing higher than ever historically observed water levels in many of the wells in the South Okanagan. Next slide, please. This is just to provide some further information. So the groundwater level data interactive map tool, it allows you to see the graphing up to date hourly as the information is being brought into the system. And you can contact myself or Twyla Ago if you have any further questions on this content. Thank you.
Nicole, thank you very much for a great presentation. Our next speaker is Doug Lundquist from Environment Canada. Doug.
Hi, good morning, everyone. Yes, it's Doug from Environment Canada, and all the presenters before me kind of set the stage for where we're at. And the biggest issue now is what the weather is going to do over the next little while. And it comes to my mind that we have really two concerns coming up for the, until fall and winter sets in. And one of them is, how do we get through this flooding season? And the second one is, if it turns dry and hot fast, if we miss the rains we usually get in May and June, how quickly do we switch from releasing water, making sure that the levels are as low as possible, to starting to conserve? And, I'll echo later on in my presentation what Nelson had to say about the graph skewing, right? The melt is often coming earlier with climate change. And also perhaps the snowpacks are starting to look like, perhaps, they may be higher because warm air can hold more water. And we've seen over the last few years higher snowpacks. So causes problems in the spring. But then again, on the other end, we have to worry about the end of the year when if we have a longer period before it cools off, we'll still have a demand on water. And also it takes longer for the fall rains to cool us off and start to give us more supply back again. So anyway, I'll talk about the seasonal forecast and the upcoming weather here. I just want to remind you that there's limited skill in seasonal forecasting, especially for precipitation. So based on that, this year I'm almost wondering if we perhaps should talk again in about a month when we have more information about what's happening in June, because it'll set the tone for what we need to do for conserving or releasing water supply for the rest of, much of the summer. But just give you a hint that our outlook is for temperature is that the summer is likely to be hot, and that part of the seasonal forecasting is much more reliable. The monsoon rains that we get in May and June are really, really important because they help us carry through the summer. If it's dry in May and June to early July, then often it'll switch from wet or from worries about flooding to possibility of fire. And it's too early to say that, honestly. Nobody can really say beyond about 2 or 3 weeks how much precipitation we're going to get. Yes, we can talk about temperature, and if it's hot and dry, that definitely is one factor. But if it's really rainy up until the beginning of July, that can often help us out. And as you know, there's a lot of water around right now, and that's what's keeping me busy right now. It's a worry about way too much water. So this is the forecast. I just updated it earlier this morning for the next week, and I have really significant concerns over this week. It's been hot and fairly sunny with high freezing levels well over 28 to 100 meters to well into the 3,000 meter level for the last week or so. And that's really resulted in what David Campbell had to say about the freshet really getting going. But my concern is that we have a system moving in for tonight into Wednesday, an upper low system. And these are kind of tricky to forecast. We know that there will be fairly heavy rain somewhere, perhaps as high as 30 millimeters, maybe 40 locally across the southern interior. But the part that's difficult is to pinpoint exactly where that'll be. So what we're going to say is that, it's going to happen in sort of this area, but some watersheds will get much more than the other. So basically right now, our current thinking is that the Okanagan is likely to get hit. So we'll probably have something like 5 to 10 millimeters of rain overnight tonight and early through the day tomorrow, and then another 10 to 20 throughout the day tomorrow. So all total, that would be 15 to 30 millimeters of rain. And there is a risk of thunderstorms developing in the afternoon. And the problem with that is they can add another 5 to 10 millimeters of rain in a really short period of time. So this is my concern, that if that adds to a watershed that's already flowing near or getting close to maximum capacity, it could cause a problem. And, so getting through at least the smaller creeks till Thursday or Friday here is my concern. And then in the longer term, though, the weather gets warmer again. We're forecasting highs as high as the high 20s for Sunday, maybe into Monday. And that'll get the melt go at mid and high elevations, right, and start to affect those bigger rivers that David Campbell talked about. So weather is very important for the next little while. And I'm going to try and give you a longer outlook at what's going to happen, but remembering beyond about a week, the precipitation input is somewhat difficult. So this is the probability of above, near, or below average temperature for the month of May. So basically for the rest of the month. And the square is around the southwest interior where we live. And basically, white means it didn't pick any of the three categories. It didn't pick warmer than average. It didn't pick close to average or below. It means they're all perhaps right about 1/3 chance, all three of those categories. So the problem with that is we can't really say a lot. In fact, that's probably good news. It probably means periods of hotter than average weather, some periods where it's colder, and some periods where it's close to average. So the month of May, if this works out, from a temperature perspective, that would be good if it's, somewhat in the middle ground. But in the longer term, I have concerns because this is the forecast for summer. We, in the Met Department, consider summer to be June 1st through to August 31st. Those 3 months are more closely tied with the hottest months of the year than the astronomical seasons. And if you look at the square there for us and just southwest of us, looks like a really high probability that the summer will be above average, something like a 2/3 chance that our area will be warmer than average throughout the summer. I don't have numbers to quantify exactly how much that would be because there's still the flip. There's still a 1/3 chance it'll be near or below average, but a high probability it'll be above average. The problem with above average temperatures is higher than average usage and higher than average evapotranspiration. So some key points here is that we're starting from a really wet point, and for the next week or so, we're worried about possible rain leading to flooding. The outlook is that there's a high probability of hotter than average summer, which would mean more evapotranspiration, but the rest of May and June rains are critical. And, there is a possibility that late summer we can get convection that can help replenish water supply if we turn the tap off, say at the end of June, like we did last year. But I just want to really point out that right now, my concern is that we should be letting water go where possible, because May and June, we could easily get way more of these upper low situations. The upper lows that we're getting now because of climate change often hold more moisture than they did years ago. The freezing levels are higher, therefore we get rain on snow. So if we're trying to hoard water in our reservoirs, we could be putting humans, our property, and the environment at risk by the potential of disastrous flooding happening in some of the watersheds. But the key point is, at some point here in the smaller, lower watersheds, we'll have to turn the tap from getting rid of water to saving water really quickly. And the higher elevation fed watersheds, maybe in June, we'll have to turn from getting rid of water to saving it quickly, because the length of time between when the freshet is done and the replenish and the longer likelihood of a warmer, longer summer means that we're going to have to get through a longer period before we can start to let down our guard in September, October. October, that time frame. And I certainly can answer any questions if that's possible here, or later. We'll do it later.
Perfect. Thank you very much, Doug. That was excellent.
You're welcome.
All right. And now for our final presenter, Ray Crampton from Flanneau RD. Ray, take it away.
Yeah, good morning, everybody. I'm here to provide a sort of a long-range fire weather forecast, a bit of a predictor of how the year is starting to show up. And as with Doug's, once you get into the long-range predictive modeling stuff, it's a large degree of uncertainty that goes along with that. That said, things are shaping up for another interesting year. Hopeful that it's not as interesting as last year. And this first slide shows just the magnitude and scale of the catastrophe of last year, with you know, what I would refer to as a below 10-year average number of fire starts, and an almost 10-fold increase over average for number of hectares burnt. And of course, you can see the triple the average 10-year rolling average for fire suppression costs. And we all know that that was primarily focused in the caribou. And just for an order of magnitude with respect to how devastating this was for those caribou communities and the natural resource sector, that 1.2 million hectares of forested timber that burned represents approximately 6 years of allowable annual cut in the entire province of BC. So it's quite a devastating loss on many fronts. And the socioeconomic recovery, along with the wildland recovery, is going to take a decade. So hopeful that we don't see that kind of year again. The indicators that we use in our rough modeling are the previous year's drought codes, the large-scale weather pattern that Doug alluded to and was showing us, the overwinter precipitation that he showed us, and the spring temperature and precipitation forecast, along with summer temperature forecasts. And as Doug was explaining to us, La Nina is on the decline. We're heading into this neutrality. The effects typically linger, as evidenced by David's continued indicating the continued accumulation of water and snow at the higher elevation into late April. And the long-range weather forecasts are starting to trend, of course, towards warmer by late spring, as Doug alluded to. So here is the spring temperature forecast, long range, of course. The take home from this, it's indicating that the forecast is for drier and warmer. This fire severity map from the Federal Natural Resource Department is indicating that we'll be at a moderate to high fire severity risk. That's for the month of June. Next slide. And for the summer temperature forecast, as Doug was showing us, warmer and hotter is likely what we're going to see. And this is the forecast severity anomaly map for August. Perhaps getting closer to normal, but could also be a hot August as well. Summer temperature forecast, warmer than average. So in summary, we came into the winter with low fuel moisture, and it's kind of ironic that with higher than average groundwater, higher than average snowpack, we've got lower than average fuel moisture, and I think that's a direct result of the successive years of drought that we've seen with warm, dry August and Septembers, which would tell us we may well be headed towards drought conditions again this August. There's the near or above average snow accumulations. Forecast for the slightly warmer, drier than average conditions, and a good chance of a hot summer, all means that we're lining up for the potential for a high-risk fire year. The history of fire, severe fire years in the South Okanagan, the Okanagan, has been we see a major fire season every 5 to 8 years. That said, the conditions for a major fire season seem to be in play every 4 to 5 years. So, like Doug said, a lot of weather luck and a lot of chance will we'll determine just what kind of year it's going to be, but it is trending towards a drier, warmer summer than average, with I would say a higher likelihood of fires than the average year. That's it for me.
Ray, thank you very much. That was an excellent overview of what we might be anticipating for forest fire risks coming up. I'm just going to finish up here with a couple of slides that really relate to the Okanagan Basin Water Board. We've got some projects going on, including looking at streams and stream management that's been taking place over the last couple of years. And of course, from a local government perspective, there's been a number of plans, and I think we're going to see more of this, of floodplain mapping throughout the Okanagan region to be able to support years like this and some of the planning events. The floodplain mapping activities are going to be enhanced by some of the LiDAR flying that has been occurring over the last couple of weeks, and then will be taking place again in August. And this is one of those important both planning and management exercises that will help communities in future years. And then, as always, the Okanagan Basin Water Board continues to emphasize this one water framework of the Okanagan, and the need for us to be able to have these kind of communication events where we really do get an understanding and a snapshot of multiple levels of hydrology and how a number of these different indicators impact communities, people, and the environment. So with that, we're pretty much right on time. I'd like to once again thank the team that pulled this together. This is one of the busiest times of the year for all of these professionals, and so I really appreciate you taking the time to spend with us and provide for this really important update. As noted earlier, there may be an interest to have a third and a final workshop in June, just to identify what the drought issue threats are coming into July and August. And so we may have that conversation moving forward. With that, I hope everybody has a good day and everybody stays safe out there. Thanks so much for joining us. Have a great Tuesday, everybody.
Thanks, Nelson.
Thank you.